Now we shall see that the process modulation. We have a signal wave which is a low strength waveform having very low frequency, audible wave having the frequency range in between 20 Hz to 20 kHz. The another one is the carrier wave which is having very high frequency. This is the carrier amplitude EC versus T. Similarly here it is the signal amplitude is ES with respect to T. Now as we have already stated that this is the carrier wave with which we are carrying the signal wave for the longer distances. Now how to send this low strength signal to the longer distances? Question arises that how to send this low strength signal. The answer is that if we make certain changes in the characteristics of the carrier wave in accordance with the signal wave, so that it is possible to send the signal wave or the information to the longer distances. So modulation is a process in which some characteristics of the carrier wave, that is like amplitude, frequency, phase, these are the characteristics which are to be changed in accordance with the signal wave. So that process is called as modulation, and the device which is used to do so is called as a modulator. Okay, modulation and modulator. Modulation is a process in which some characteristics of the carrier wave are changed in accordance with the signal wave, and the circuit which is used to do so is called as a modulator. Okay. Now we shall see that what is the need for the modulation. Why we need modulation? There are three basic reasons why we need modulation. I will explain. Number one is the practical antenna length. Practical antenna length. We have a signal having low strength and low frequency, so that we cannot send this signal wave directly into the atmosphere, and if we send this directly into the atmosphere, it will not cover larger distances. Therefore we need modulation. Okay. Now theory says that the length of the antenna should be proportional to the wavelength of the wave. Now we see that the wavelength of the wave is given by lambda is equal to velocity divided by the frequency. Now as already we have stated that the wave travels with the velocity of light velocity, that is 3 into 10 to the power of 8 meter per second, that is 3 into 10 to the power of 8 meter per second, and the maximum frequency which we use here as the range of audible range is 20 Hz to 20 kHz. Now if we make use of the maximum frequency, that is 20 kHz, 20 into 10 to the power of 3 Hz, so that this will come to be 15,000 meters. So the antenna length required should be 15,000 meters. It is impracticable to construct such a length antenna with such a length of antenna. Therefore, on the other hand, if we change this frequency, in the sense, if we make use of the high frequency carrier wave, here in place of 20 kilohertz is the maximum frequency, audible frequency. If we change this one as to be 1000 kilohertz as the carrier wave frequency, so that this will come to be near about 300 meters, and construction of 300 meters antenna is possible. Therefore, we need modulation process. Okay, so the another reason is that operating range. The energy of the waveform is directly proportional to the frequency. Now, as already we have stated that the signal wave is having low frequency, therefore automatically it is having low energy. And if it is having low energy, in the sense it will not cover larger distances if it is to be radiated directly into the atmosphere. Therefore, it must be, that is, some changes are to be made in the waveform to send it for the larger distances. Therefore, this is one of the reasons as the operating range, because it is having low strength, because it is having low frequency, it cannot be radiated directly into the atmosphere. And the third reason is that we need modulation is that is, it's a wireless communication. It's a wireless communication. To send this low strength signal wave into the atmosphere, as it is having very low frequency, as it is not possible, as already we have stated. So it is, we are not using any type of wires to send this signal from one place to the another place. To send this signal, we require the high frequency carrier wave, and so that the high energetic wave will be sent directly into the atmosphere. Therefore, that is, it's a wireless communication. Therefore, we need the modulation. By these three reasons, we state that the modulation is must to send the signal from one place to the another place. Now we will see that the types of modulation. Types of modulation. As we have stated that by changing some characteristics of the carrier wave in accordance with the signal wave, the process of modulation is to be obtained. Now, the characteristics, as if we change the characteristics as amplitude, so we call that type of modulation as an amplitude modulation. On the other hand, if we the other two are to be kept constant, frequency and phase. On the other hand, if we change the frequency, so we call that type of modulation as an frequency modulation. And the third one is if we change the phase of the carrier wave in accordance with the signal wave, so we call that type of modulation as phase modulation. So there are three types. One is the amplitude modulation, the second one is the frequency modulation, and the third one is phase modulation. Okay, three types are there: amplitude modulation, frequency modulation, and phase modulation. In amplitude modulation, the the amplitude of the carrier wave is changed in accordance with the signal wave. The other two are kept constant, is called as an amplitude modulation. In frequency modulation, the frequency of the carrier wave is changed in accordance with the signal wave, keeping the other two, amplitude and phase, of the carrier wave constant, is called as frequency modulation. And the third one is the phase modulation. The characteristics phase of the carrier wave is changed in accordance with the signal wave, keeping the other two, amplitude and frequency of the carrier wave, as constant, is called as phase modulation. Okay, so one by one we will see. Before going to know about one by one, we will come to know that what is the modulation factor, which plays very vital role in the modulation. Modulation factor. So, in case of the amplitude modulation, the amplitude of the carrier wave is changed. Okay, amplitude of the carrier wave is changed. This is the carrier wave. So this is having the EC as its amplitude, and the another one is we have here is as the signal wave. So this is having the amplitude as ES with respect to T, and the third one we will show here as the modulated wave. So here we are changing the amplitude of the carrier wave in accordance with the signal wave. So we are changing the amplitude of the carrier wave in accordance with the intensity of the signal wave. The information is always contained in the variations of the amplitude of the carrier wave. As the signal wave is, the intensity of the signal wave is raising, so that we are increasing the amplitude of the carrier wave. So you see this one, we are raising the amplitude every time, right? Now it has been raised again to the higher one as the signal amplitude is to be increased. On the other hand, when the signal amplitude is falling down, so that we are also reducing the amplitude of the carrier in accordance with the signal. So this is the amplitude modulation. Okay. Now the modulation factor, which we are going to say something about it, is playing very vital role in the modulation process. Modulation factor. Represented by small m. It plays very vital role in the modulation process. The changes which we are making in the carrier wave, up to what extent we are making the changes, up to what depth we are making the changes in the carrier wave, that is to be known with the help of the modulation factor. Now, the definition for the modulation factor is given as it is a ratio of the change in the amplitude of the carrier wave to the normal amplitude of the carrier wave. Okay, modulation factor M is defined as it is the ratio of the change in the amplitude of the carrier wave to the normal amplitude of the carrier wave. Now we shall see by some examples how it is affecting on the modulation, the modulation factor. Say that first of all we will take the this is the amplitude of the carrier wave. Say this is A, we will call this one as A. This is represented with the carrier wave EC and T. And now to the another one, we take the amplitude of this signal wave to be 0. Okay, amplitude of the signal wave to be 0, so that the change in the amplitude of the carrier wave is 0. Okay, so we get here to be 0, and the normal amplitude of the carrier wave is A. Therefore, this comes to be 0, so that we get the 0% of the modulation. Therefore, here we are not getting any type of modulation, only the carrier wave is to be seen as it is. Okay, there is no any modulation, only the carrier wave is to be seen when the signal amplitude is 0. Now we shall see that if we take the signal amplitude to be 0.5% of the amplitude of the carrier wave. Okay, now this is the amplitude of the carrier wave and this is the amplitude of the signal wave. This is represented by ES. Okay, now we will find that here the change in this carrier wave will vary in between 0 and 0.5 times the A, isn't it? So that this will be 0.5 times A divided by A. This A will get cancelled, so that we get this as point. Right? This will be 50%. So that the modulation which we find as 50%. Modulation which we find as 50%. Now the third case we will see here. So this one we will take it as the amplitude of the carrier and the signal wave is also, this is also A we will take, that is the amplitude of the carrier wave and the amplitude of the signal wave both are same, equal, so that the changes we see here as 2A times minus A is the normal carrier amplitude changes to A, so that the total change which we have obtained in the carrier wave is equals to A. Now the modulation factor is to be calculated for this one as, okay, so the change we got here as A and normal is A, therefore we get this is to be 1, that is 100% modulation. When we take the amplitude of the carrier wave is equals to A and also the amplitude of the signal wave is equals to A, so that the change we obtained, the change in the amplitude of the carrier wave to be A. Therefore, this modulation factor we take it as A by A will be 1, that is 100%. So that we get here the modulated wave as 100% modulated one. So this will be the 100% modulated wave. Okay, this will be 100% modulated wave. Now the last case we will see that if this is 1.5 times A, if this signal amplitude is 1.5 times the A, so that the carrier will vary. The carrier amplitude will vary from 0 to 2.5. So this is 2.5, right? 1.5 A and A, it will be 2.5 A. Therefore, the change in the amplitude of the carrier wave will be, it is 1.5 times A, right? So that this will be 1.5 times A divided by the modulation factor is to be calculated as change in the amplitude of the carrier wave, which we have obtained as 1.5 A. So this is 1.5 A. Now normal amplitude of the carrier wave is A. Therefore, this A will get cancelled. We are left with this 1.5. So that the modulation will be now here as 150%. Okay, 150%. So that we get the modulated wave is over modulated or distorted. We will say that the sum of the envelope has been clipped off. Sum of the envelope has been clipped off here. Okay, this is 151. So by these four cases, we will come to the conclusion that as the signal wave is in the variations of the amplitude of the carrier wave, if it is below 100%, so that we will not get the good quality of the modulation and the reception will not be a good one. On the other hand, if it is 100%, so the modulated wave transmitted will be 100% and the waveform which is to be received at the receiving station will be, the quality of that wave will be good one, good enough. On the other hand, if it is over modulated, that is 150%, so that we will find that the distortion is to be obtained. On the other hand, we will say that the envelope is to be clipped off. Therefore, the modulation factor plays very vital role in the modulation process. We will